So let's get started. Architecture of Linux. Here's a visual representation of Linux architecture, including its hardware, kernel, system libraries, shell, and user applications. The structure shows how the different layers of Linux interact with each other. So the architecture of Linux is layered, with each layer performing specific functions and interacting with other layers to provide fully operational system. Here's a breakdown of each component. Its hardware layer, kernel, system libraries, shell, and user applications. The hardware layer includes all the physical hardware components of a system, such as CPU, memory, storage devices, and peripherals like keyboards and network cards. The Linux kernel is the core part of operating system. It manages hardware resources and allows software applications to use them efficiently. It serves as a bridge between hardware and user applications. The system libraries provide the standard interface through which applications interact with the kernel. The most notable is the GNU-C library, which offers functions like input-output processing, file handling, and memory management. The shell is a user interface that allows users to interact with operating system. Some common shells include bash, jetsh, and fish. User applications is the top layer, includes all the user level software like text editors, web browsers, and office applications. These programs rely on underlying system libraries and kernel to function. So to describe the overall flow, users interact with the shell to give commands or run applications. The shell passes this request to system libraries. System libraries use system calls to communicate with the kernel. The kernel manages the hardware resources to fulfill these requests, like processing a command or running an application. So each layer abstracts complexities for one above it, providing a smooth functional experience for users and applications. And to describe what are the kernel tasks, so it performs the process management, like managing the CPU time, and allows process to run concurrently. It also does a memory management, handles memory allocation for process, and manages virtual memory. Provides interfaces for hardware components like printers, hard drives, and network cards. System calls and control allows user programs to interact with kernel through system calls, which provide access to services like file management and I/O operations. I/O management manages input and output operations like reading from disk, writing to files, or handling network requests.